For this lesson, we're going to talk about the application of Newton's second law. Welcome to Physics is Easy with Mr. Jesse. A block of mass m equals 1 kilogram and a ball with a weight of 5 newtons are connected by a light string that passes over a frictionless pulley as shown in figure A, and force diagram of the block and the ball are shown in figure B. So first question, what is the normal force acting on the block? So if we're going to look at figure B, the forces that are acting on the block are namely, we have the normal force, so that's N right there is the normal force. We also have the force of gravity, which is equal to the weight of the block. So the weight of the block, let me write that down, it's just equal to m1g. And we have friction, and this one right here is tension. So let's look at the first question. What is the normal force acting on the block? So according to the free body diagram, the normal force is actually equal to that of the weight of the block. So, and that is because we will not be able to observe this object right here going up or down, because if the normal force was greater than the weight of the block, then the object would go up, or if the weight of the block is greater than the normal force, then we would be able to observe the block to be going down. But since it's not going anywhere up or down as far as the vertical axis is concerned, then we could actually say that the normal force is just equal to the weight of the block. So having said that, we could say F net in the y-axis is equal to the normal force plus or minus the weight of the block. So this is minus mainly because normal force is directed upward while the weight of the block is directed downward. And once again, the net force or the sum of the forces in the y-axis is 0, so I'm gonna call that 0. Rather substitute that with 0, and that is equal to the normal force, which is what's being asked in the first problem, minus the weight of the block. So substituting the values or expanding the equation, I will have the normal force N is equal to the weight of the block is just equal to the mass of the block m1 multiplied by g. So I will have the normal force is equal to minus m is equal to 1 kilogram multiplied by the magnitude of the acceleration due to gravity, so that's going to be 9.8 meters per second square. So once again, take note that if we are dealing with problems that involve Newton's second law, g would be positive 9.8, or meaning we're just going to take the magnitude of the acceleration due to gravity, contrary to when we're dealing with equations of motion wherein g would always be negative 9.8. So manipulating this, we will have 0 right there. So we will have N is going to be equal to 9.8 newtons. And if we are going to use G as 10, so that would be approximately 10 newtons. Number 2, what is the mass of the ball? So if we are going to look into the equation for the weight of the object, so weight is equal to mass times acceleration due to gravity. In the problem, we're given that the mass of the ball is equal to 5 newtons, so we just have to substitute that value, 0.5 newtons, that is equal to the mass of the ball multiplied by acceleration due to gravity. Again, that's going to be 9.8 meters per second square, positive, because we are dealing with Newton's second laws, not equations of motion. So then this would give us m to be approximately equal to 0.5, and do not forget the unit, that should be in kilograms. Okay, so that's our answer to the second question. Question number 3. If the ball moves down with an acceleration of 2 meters per second square, what is the magnitude of tension on the rope? Okay, so that means we will have to be looking into this diagram right here, since we are interested in we are interested in the motion of the ball. So by virtue of Newton's second law, again, in solving problems like this, it is very essential to go back to what Newton's second law says. So that would be F net. This is question number 3. F net is equal to mass times acceleration. Now when we say F net, it is just equal to the sum of the forces that are acting on the object. So if we look at this ball right here, the forces would be tension and the weight of the ball. So if the force is directed up, by convention it's going to be positive. If it's directed down, then it's going to be negative. So for example, in this case, the F net would be equal to tension, that's going to be positive, minus the weight of the ball. So we will have it negative because, again, the weight of the ball is directed downward. And that is equal to the mass of the object multiplied by the acceleration. Now for the acceleration, you have to take note where the object is moving, or its direction. So if it's going down, it should be negative. If it's going up, it should be positive. So that is our convention, just like force. So moving forward, we are interested to solve for tension. So we will have T minus the weight of the ball as given in the problem is equal to 5.0 Newton, and that is equal to the mass of the ball. So we have solved that in number 2. That's equal to 0.5 multiplied by the acceleration. Now it says here the ball moves down with an acceleration of 2 meters per second. So meaning to say the acceleration should be negative because the object or the ball is going down. So there's going to be negative 2. Simplifying this, we will have T is equal to 5 minus 0.5 times 2 is equal to 1. So that's T is equal to 4 newtons. This is the answer to question number 3. So tension is equal to 4 newtons. Now let's move on to question number 4. Question number 4, find the magnitude of friction acting on the block. So if we're going to look at this figure, right, friction is acting on the x-axis. So we say F net is equal to MA, and in this case we will be looking into the x-axis because that is where friction is located or a part of. So again, let's remember our Cartesian coordinate. This is positive y, negative y, and on the x-axis this is positive x, and that is negative x. So if the force is directed to the left, it should be negative. If it's directed to the right, it should be positive. Okay, so we have F net is going to be equal to tension, because that's going to be positive, minus friction, Fk, because that is directed to the left, and that is equal to the mass, and this time it's going to be the mass of the block multiplied by the acceleration of the block. So in this case, the block is going to the right, so it's going to the right, so therefore the acceleration is positive. All right, so tension, this tension that we have in number 4, is equal to the tension that we have in number 3. So that means then if we're going to look into this diagram, the tension, this tension right here, is equal to the tension that is acting on the ball. So always remember that if they are connected with a single string, the tension that is on the string is going to be equal for both objects. Okay, so now that we have tension, that's going to be, let's substitute those values. So we have 4 minus friction, which is what we need to solve for, multiplied by the mass. And then once again, the mass that we're going to use here is the mass of the block. So that's gonna be 1 multiplied by the acceleration, and it's going to be equal to the same as the acceleration that we have for the ball, because they're moving as one. But in this case, it's going to be positive because the object, this mass right here is going to the right. And again, by convention, if it goes to the right, it's going to be positive. If it goes to the left, it's negative. Up is positive and down is negative. So it is for that reason that this acceleration here is positive, while the acceleration that we have in number 3 is negative because the ball is going down. Alright, so manipulating this further, we will have Fk is equal to 4 is going to be equal to 4 minus 2, so friction is going to be equal to 2 newtons, and that solves this problem. That concludes this tutorial. Always remember, physics is easy with Mr. Jesse.